Okay, so today we are going to discuss about thermal expansion. Okay, in the previous topic, we already discussed this idea when we provide thermal energy to any state of matter, either solid, liquid, or gas. So the particles or like the molecules of that state of matter get some energy, and with the help of that energy they starts to vibrate or like they starts to move away from each other. In short, their energy, their kinetic energy increases, and when energy increases, so it helps the molecules to move away from each other or to vibrate more frequently. So this is the basic idea that we already discussed in the concept of the heat. And in the same way, when we provide thermal energy, for example, if we consider, so let's suppose if there is a gas in a container and these are gas particles or gas molecules, we can say. So we know that gas is in the category of in which the particles are very far away from each other and they are moving in random direction. And if we start providing thermal energy to the gas, so after some time, what happens? Molecule starts to move away from each other and they starts to vibrate or collide more frequently with each other and also with the wall of container. So we show them by increasing the distance. So their distance starts to increase, and the rate of collision also increases. Gap increases, and rate of collision also increases. So this is the scenario for thermal expansion. In simple words, if we are providing thermal energy, so molecules are moving away from each other, and when they are moving away from each other, so definitely there is like the molecules are occupying more space as compared to the initial stage. So this process is called thermal expansion when the molecules are occupying more space as compared to their initial stage. And if we compare three states of matter, solid, liquid, and gases, so expansion will be greater in gases because they have weak intermolecular forces and they are already very far away from each other. So thermal expansion or thermal expansion rate of thermal expansion will be greater in the gases as compared to solid and liquid. In solid, we know molecules are very tightly packed. So definitely we required more energy to break their bonds and to move them away from each other. So thermal expansion simply means it is called increase in gap between molecules. of a substance when heated. And if we compare three states of matter, so among these three states of matter, so the first thing is thermal expansion, will be greater in gases because the molecules are free to move. So in gases, we know molecules are already free to move. So definitely when we provide thermal energy, so it will be easy for the molecules of the gases to move further away from each other because they have negligible intermolecular forces. So definitely there is very low resistance for them. So there is very easy way to for the molecules to move further away from each other. But if we compare with the solid, so thermal expansion will be least in the solid or in the solid state of matter, and the reason is simple because molecules are very tightly packed, they have strong intermolecular forces. So to break their bond, we required more amount of thermal energy. So that's why expansion or thermal expansion will be least in solid state of matter. Thermal expansion released in solid because the molecules are tightly packed and they have strong intermolecular forces. So this is the concept of thermal expansion. There is no formula for thermal expansion. There are no other factors for thermal expansion. So this is a very short, simple topic related to the thermal energy. So now in thermal energy, basically we discussed about specific heat capacity. We have formula of specific heat capacity. We also discussed about boiling and evaporation, what is the difference between them? And we also discuss what are the factors affecting evaporation. And after that, in this chapter, we also discuss what happens and why temperature remains constant during the change of state. We discuss in heating curve, we discuss cooling curve. So that is also the topic of thermal energy. And today we discussed about thermal expansion. So these are all thermal properties related to the states of matter, or that we can apply on states of matter, right? So any question, any confusion in this?
No, sir.
Okay. So basically, in the start, as we discussed, there are three chapters in this thermal physics section, right? The first one is related to the basic kinetic properties of matter. In basic kinetic molecular theory of matter, we have to know about solid particles or solid state, liquid state, gaseous state. So you already know about it, right? In the first class, you also mention points by yourself that molecules are tightly packed, they have fixed shape, fixed volume in solid, and same like for liquid and gases. So that is the first chapter. And in second chapter, we discuss about thermal properties, different type of thermal properties, specific heat capacity, evaporation, boiling, etc. So these are the topic of the second chapter basically. Now we are also going to start the topic of the third chapter, that is transfer of thermal energy, right? So this is the third chapter of thermal physics. Yes.
Sir, I want to ask that
Hmm.
the this topic of thermal expansion is the part of which chapter, so that when
Thermal
like
properties.
prepare.
Thermal properties.
Okay, so that chapter is done, or we are continuing the same chapter right now?
Basically, now we are actually going to start the new chapter, but it is not compulsory to just remember the name of the chapter, right? If you know about the topic, so that's enough. We just conclude it in a simple way that these all are the topics of thermal physics section. Simple.
Yes, but it gets easy when like
Yes.
having some
Okay.
references as well.
Basically, this is the first chapter, right? Kinetic properties of matter. This is first. And in this kinetic properties, the properties of solid, liquid, gases are included, right? And the other
Yes.
two chapters are thermal properties and transfer of thermal energy. So after kinetic properties of matter, we started thermal properties from here. So this is actually the chapter thermal properties. This is chapter number 2, thermal properties. Because in our new syllabus, like that is designed first for 2023 exam, the topic of thermometer, the topic of latent heat is now excluded. So that's why this thermal section becomes very short and very simple. So from this sensible heat topic, we started thermal properties, and thermal properties is a detailed chapter. As you can see, there are so many topics in it. So these are all the topics of thermal properties. This is also the topic of thermal property. Now the topic we are going to start is related to chapter number 3.
Okay, so sir, in a way we finished chapter number 2,
Yes.
thermal properties. Okay, thank you.
So right now we are talking about transfer of thermal energy. Because thermal section or like thermal chapter, I choose this section first because this is simple, short, and it is more related to the theoretical knowledge, right? You observe that there is only one formula, so it will be easy for us in the start of the session that to start with a simple topic. So it will give confidence and it will also help us to go through the questions of the past papers, and then we will start a different chapter after it. So in that chapter, you will find different calculation diagrams and all the things. Okay, so in transfer of thermal energy, the theme of this chapter is very simple. We need to study about three different process for transfer of thermal energy, right? And there are three different process. The first one is conduction, and the second is convection. In this chapter, we need to study about the conduction. This is the first method of heat transfer. The second, convection. This is also the method of heat transfer. And the third one is radiation. So in this chapter, only these three processes are involved. You need to study about the detail of these three processes in this whole chapter. Okay. So the first method is conduction. So if we talk about conduction. Okay. In the previous chapter, like in thermal properties, we discuss idea. Again, the same idea when we provide thermal energy. So definitely molecule gets energy and they starts to vibrate more frequently, right? And when it starts to collide more frequently, so definitely they are going to collide with other molecules and with the wall of container. Okay, just like when we start to boil water, so bubbles are going to be formed, and if there is a lid on the container, so we got some water droplets on the lid of the container because some starts to evaporate and they stick to the lid or the cover of the container. So same happens in the conduction, right? Basically, conduction is the mode of heat transfer with the help of collision between the molecules. So if we want to write the definition for conduction, so the definition of conduction is very easy. It is the mode of heat transfer with the help of collision between molecules, right? For example, if you consider the game of the snooker, so on a snooker board, what happens when we strike a white ball? So white ball has maximum energy on the board, right? Because we strike white ball, so white ball gets energy, and all other balls are in rest state. But when white ball strikes any other ball, right? So that ball also starts to move. So that the second ball or the other ball gets energy after collision, right? So after collision, white ball transfers its some of the part of its energy to the other ball. So that's why the next second ball also starts to move on the board. And let's suppose if second ball is strike any other ball on the board, so that also starts to move slightly with some speed. Okay. So in this way, energy can be transferred with the help of collision. So this is called conduction, right? So when one particle, one molecule strikes the other, so that molecule transfer its energy or some part of its energy to the other molecule, and then the other molecule transfer energy to the third, then fourth, fifth, and so on. So this method is called the method of conduction, right? And if we write down the explanation, like if they ask about explanation in exams, so in explanation, we can write, for example, if we take a candle and a spoon, right? We just light up the candle and we place one end of the spoon on the light of the candle, right? And after few minutes, uh, the thermal energy or like the heat energy is going to be transferred from the hot side of the spoon to the other side of the spoon. For example, if we have a candle, right? And if we take a rod or like a spoon, right? And we are holding that spoon from this side. So it is very simple that thermal energy is going to be transferred from this end of the spoon, and that energy also starts to transfer to the cold side of the spoon, because we are holding from the right hand side, and heat is going to be transferred from the left hand side. So this heat also transfers throughout the spoon, because a spoon helps the heat energy, or the molecules of the spoon helps the heat energy to transfer from the cold side, sorry, from the hot side to the cold side. Okay. So I am writing also the explanation. When one end of the body is heated, any other example in your mind that we use in our daily life related to conduction? There are so many examples of conduction in our daily life that we use in our daily life also.
The handle of the pot getting hot after a time.
Yes. So basically the example of the pot, the example of the saucepan. So you observe that the handle of these utensils are made up of the wood or plastic, right? Because we know if it is made up of the metal, so metal gets heat up very easily, and we are not able to hold that saucepan or that pot with the help of the handle, right? And that's why we have like wooden cover on the handle of these pans, so it will be easy for us to hold that pan.
Unless the wooden side is also burnt.
Yes, so that's why we know that the handle or like the carrier of these containers are made up of some insulator material that is not made up of completely metal, because we know that if it is made up of metal, so we are not able to hold that part of that container. So when one end of the body is heated, so atoms over there starts to vibrate more frequently, and definitely when it starts to collide more frequently, so it also starts to collide with their surrounding atoms or molecules, with their surrounding molecules. Just like the example of that snooker ball we discussed, when we strike that white ball, so definitely it starts to collide with the other one. And definitely when it starts to collide, so it also transfers thermal energy to them.
Sir, about this like candle you drew, can you explain this example?
Okay, basically we are using candle as the source of thermal energy, right? When we light up the
Yes.
candle, so thermal energy is going to be provided by the candle, right? And then we take some metal rod or like the spoon, and we place one end of the spoon on the candle, right? So when we place one end of the spoon on the candle, so one side or one end of a spoon gets thermal energy, and slowly and gradually that thermal energy starts to transfer to the other end of the spoon also, right? So from this process, actually we are going to explain the idea of conduction, that thermal energy is going to be transferred from the hot end of the body to the cold end of the body, because on the hot end of the body molecules are getting thermal energy, they starts to collide or they starts to move with more frequency as compared to the initial, and definitely when they starts to move with greater speed, so they also collides with the neighboring molecules, right? So when they starts to collide with the neighboring molecules, it means they are transferring their thermal energy to the neighboring molecules. And when they are transferring thermal energy to the neighboring molecules, it means thermal energy is now going to be transferred from hot end to the cold end of the body, right?
Yes, sir.
So the same we used to write down in the explanation. So the explanation is same for this example of the candle also, because only one end is heating up. So that heating side provides the thermal energy to the cold molecules. And after a few minutes or after some time, you observe that whole spoon is going to be heat up, and we are not able to hold that spoon because cold side is also heat up with the help of the thermal energy that is transferred from the hot side. So this is the example.
Okay, sir.
And it also shows you the transfer of thermal energy. It shows you that heat is transferring from the hot end to the cold end. So heat travels gradually from hot end to the cold end. So this is the explanation for the conduction process, right? Any
Yes,
question?
sir.
Okay.
No,
No,
sir.
sir. It's clear.
So idea is very simple. We use the idea of thermal properties and we apply on the conduction. Basically, this is a method of heat transfer. And in this method, we are using the same thermal property idea that we discussed in the previous chapter. Okay. Now, in this conduction process, let's suppose if we especially talk about the metals, right? Because in this explanation, you can see that there is no specific idea of metal is involved, right? But if we talk about conductors like metals, because we know that metals are good conductor, they can conduct heat and electricity very easily. So they are that's why they are good conductors. Okay. And what happens if we talk about the example of metals? So if we apply the process or if we use this conduction method in the metals, so what will be the difference or like what will be the advantage of using the conductors? So if we talk about metals, in case of metals. So if we talk about the case of metal, so especially in metals, there are free electrons, right? Maybe you studied in lower other secondary classes that conductors are conductors because they have free electrons, and those free electrons helps the heat or electricity to transfer from one end to the other end. So in the same way, if we are talking about the metals, so in metals we have atoms or molecules, as we already discussed. Atoms and molecules are always available, but if we are talking about metals, so we have one more special thing, that is free electrons. Okay. Basically, if we talk about conductors, because metals are also called conductors, so if we define the concept of the conductor, so the definition of conductor is very easy. Conductor are the materials having free electrons. It helps them to transfer heat and electricity. And if you compare it with another category, which is called insulators, so you will get the idea that what is the difference between conductors and insulators. So if we talk about insulators, so in insulators we can say these are the materials having electrons. They also have electrons, but the problem is but these electrons can only vibrate about their fixed position, right? So this is the difference between conductors and insulators. And just for example, the example of conductor are any type of metal, right? So all type of metals are conductors. And for insulators, plastic, wood, glass, so these materials are insulator. So this is the difference between conductors and insulators, right?
Sir, insulators could also be given the name as non-metals.
Yes, you can also call them non-metals. So non-metal materials are also called insulators, right?